morning. Let me just start from the beginning. So, as we go through the morning and start addressing some of the issues that already came up and the theme for thinking about sustainable cities, the first question almost is, why do cities exist? What is it that they do? How is it that we understand built space, the way they structure our time, the way they structure our social lives, and the way we can, because it's only from the point of view of having a deeper understanding of what these complicated social technical systems are, that we can imagine what they can become in the future and perhaps plan them in better ways. So the title of my talk today, A New View of Cities as Complex Systems, is really Ingvar's title, but I liked it, so I decided to keep it. But I'm not sure it's necessarily a very new view. It's a view that existed certainly in planning since Patrick Getty's one of the first planners at the turn of the previous century. And it's this idea that you really cannot understand cities from very narrow perspectives. You can think, of course, of the city as an engineered system, or as a purely social system, or perhaps a market, a sort of kind of localized market. But in some sense, all these perspectives miss the point a little bit. You need to understand how they integrate with each other. And so the view of the city as a complex system really is the idea of asking the question about integration. How is it that we understand socioeconomic life of people in the kind of built environments that we construct? And vice versa, what is the nature of these built environments such that cities as socioeconomic systems work well? So hopefully today I'll give you some of the answers for what we know so far about cities from this perspective, but also I think we'll start informing some of what you can imagine cities can be. So I want to start not so much with science or engineering, but with poetry, if you allow me. And it's actually, I had this to start the talk to begin with, but it's very consonant with the little clip from 2001 that you saw just as in the opening screen of this event. And so I think all of you have seen 2001, right? It's sort of the most famous films ever made. But there's a little secret that I'm not sure you've thought about. That movie, I think, came out in 1968. And it was therefore shot in the years before. And when you see that opening shot where we look at the Earth from the outside, they had not seen the Earth from the outside. That's what they imagined the Earth to be. And the Earth actually doesn't quite look just like that. It was an act of imagination to see what the Earth was and sort of to play to this big cycle of what humans, where they came from and where they've become. And so this little excerpt from T.S. Eliot, so the great English poet from St. Louis, Missouri, is really about this, about looking at something that we're very familiar with, in this case cities, things that, environments where we live all the time, but coming back to them and try to understand them for the first time. So I hope that will make some sense of that. Okay, so we often think about cities as sort of engines of economic change, economic growth, and creativity. And so this is sort of important because there certainly are that too. But here's one way in which this is usually understood or at least invoked. So what you see here is just a general simple plot where on the y-axis you have basically GDP per capita, so a measure of economic development. And on the x-axis you have by country the percentage of people that live in cities. And so the general feature of this is that these curves are going up as nations get urbanized. So that means that economic growth in some sense is strongly correlated with urbanization. This is something we've known for a long time, both sort of historically, not very well, but also in contemporary times. But you also see a few little features that are very interesting. So if you look at some European countries over here, so there's Britain, I don't think Sweden's here, but you see that it's enough to be urbanized and you can continue to grow in some cases. But you also see countries like Brazil that have been urbanized for a while, but that do not create necessarily economic growth. So cities seem to be necessary, but not sufficient. So it's important to think about what is it that cities create as environments that allow, in this case, economic change. But also it's important to ask, when is it that they don't work? Or at least they don't deliver on what we may think are the obvious things that cities can do. So cities are also, I think, this one's familiar, but there are a lot of ways in which cities are not purely economic systems. They're social systems. This is my own city of Santa Fe, New Mexico. So it's an old Spanish city in the United States. But we have this tradition at Christmas to have lights. Also somewhat a Swedish custom in a different context. But, you know, there are many ways in which cities can be good or bad as places for people to live. And the quality of what makes these spaces interesting have to do a lot of what are the social uses and the social activities and the kind of things that we can do together, among strangers mostly, that creates good urban spaces or bad urban spaces. So this is a little pixelated, but you might have seen this from BBC. But it's, you know, China is one of the great places for experimentation in cities, not because they want to be experimenting, but because they're building a lot. So this is an intersection. I think it's in Beijing. But, you know, problem of traffic management, don't need to say it, but also this kind of problem, right? The problem that as cities develop, they don't just create good spaces and economic growth. They create all kinds of other things that are related to the need to move, the need to interact, the need to build artificial spaces. And, you know, the problem of air quality, this is Beijing, but now in fact, I was just in Mumbai 2 months ago, and India now has worse air quality. Most Indian cities, Delhi in particular, has worse air quality than China, and they're no way close to finishing their urbanization. In some sense, they're just starting. So there are issues of really whether these spaces and the fast urbanization that we're seeing throughout the world, which is mostly really in Africa and in Asia, and of course in Europe and the United States and Latin America, we see different kinds of urbanization, sort of better urbanization perhaps, are creating spaces that are good on the balance or are bad. So in some sense, the nature of cities is always to create these tensions, is create both the good with the bad. And the challenge for all of us as scientists, as technologists, as people in business that work in improving socioeconomic life in cities, the tension really is to understand the good things and why they come about, and to understand how the bad things can be worked out of the system in some sense. Of course, we know we don't have to have bad air quality just because we have cities, but there are a lot of technological changes and choices and policies that will have to happen in order to change the situation. Okay, so the question is sort of a more ambiguous picture. This is Rio, but it's a question of a lot of cities are really being built this way, by hand, locally, by people. A lot of our work now is in developing cities, in small slum neighborhoods, and this is really the challenge. It's not clear these places are sustainable. It's clear that they're providing some opportunities for a lot of people, about 1 billion people all over the world to change their lives, and people are coming. But it's not clear if this is a clean path for improvement or a trap. So there's really a sense in which this is the tension, and this tension that plays out so obviously in the cities of India and the cities of Brazil is a tension that is there in our own cities. I'm sure we were talking a little bit, of course, about Stockholm, but any other city, I don't know Stockholm well, but any city has neighborhoods that are thriving and seem interesting by most people's standards, but also other places that are challenging, that people are trying to fit in, they just came in, they may not be able to understand society, take advantage of its opportunities, and sort of vice versa. So this dynamics of integration at the edge of the city, of built spaces that work, and the socioeconomic life of being integrated in these large social systems is challenging and happens everywhere. So my own work started about, now I think 12 years ago or something, really on cities. And this idea of complex systems is really to start asking, what is it that we can say about cities in an integrated way that's also quantitative? How is it that we can use data to start telling us something about these super, super complicated spaces and networks, okay? So, and the answer is interesting, but must be complicated to some extent, because at once we want to be able to say that there's a lot of similarities between cities all over the world, and some of that is more or less obvious, but I'll show you also with data. But a lot of it has to do with the fact that each place, each person, each neighborhood has to also be different. So how is it that these two things come together and in fact leave room for cities to continue to change and be these places of growth and creativity, and yet also that they can be described by data and by mathematics, as I'll show you a little bit of? And how is it that this tension really works out? So this actually is interesting scientifically as well, because it forces us to think about science in a realm for which we really have not had a lot of quantitative theory, and apart from some places in economics, etc., but it's sort of in a new, more integrated way. Okay, so the exercise I'll go through today is basically the idea that you want to bring all the disciplines, both technical and more theoretical, that look at cities, all the points of view, and really integrate them all together and sort of create something that is new, a synthesis, but that also is driven and is checked with data and experiments. So I want to emphasize that that is, of course, to some extent new, that we now have data coming from basically almost every city on Earth. There are about 4,000 cities above 100,000 people in the world, so it's a sort of countable number. So if you want to know the numbers, about 4,000 cities like that. They're about a factor of 1,000 in terms of that neighborhood. So there are probably a few million neighborhoods, and of course a few billion people, about 4 billion people in cities in the world today. But this is not new either, right? I mean, being in Sweden, I have to say this, that you've had extraordinary socioeconomic data about people in cities and elsewhere for a long time. So the question really is, how can we ask questions that break this open and allow us to do new work, both that's scientific but also technical and applied in terms of policy. So let me show you how we've been going about it. And I'll start basically with a very aggregate picture, looking at entire cities at once. And then as the talk goes on, I'll start telling you more about neighborhoods and local places and diversity and change in cities, because that's, of course, more complicated and you have to build up to it. So the first question really is, why cities even exist? What is it? What are the dimensions of cities that we can identify as reasons for cities to exist and grow? So what you see here, most of this is American. This is all American data in this case, but it's 40 years of wages. So basically, you go to different cities in the United States. Each one of these points is a different city. These are cities, the metropolitan statistical areas, so they're metropolitan areas. And these are all the ones that are about 50,000 people. So in the US, there are about 366 now in this category. And what you see here is basically it's basically the simplest thing you can do. On the y-axis, I'm plotting wages. I kind of normalized it so that all these curves fall in the same center. And on the x-axis is basically just population, so it's a measure of size. And so, for example, these points here, if you see this little cloud here, is New York City. Okay, so it's the largest city, but you also see that the largest city is the one that pays, on average, the highest wages. So this is typical. I'm sure it's probably true of Sweden as well, that if you live in Stockholm, on the average, there's a lot of dispersion, but on the average, you probably earn more money and spend more money than you would in a smaller town. So this is a general characteristic of cities. It means basically that the value of labor per unit time is higher in larger cities, which is kind of an interesting thing to think about, if you think about it. So there are all kinds of professions, all kinds of services, but the value of labor in larger places, when you put people largely doing some of the same things and also some new things relative to other cities in the country, earn more per unit time as that happens. So, and so what you find is that basically this is a simple power law. It has this relationship. It's simple enough. This beta parameter is the slope. And basically it's the fact that this slope is on average larger than 1, which is this, 1 would have been this line, that's telling you basically that this is what economists sometimes call increasing returns to scale. So as you make a system bigger, you actually are getting increasing returns, that wages, the value of labor per unit time, is getting up. This is the same thing, but it's GDP now, not wages. So it's very related, but it's not the same thing, as you know. And this is now 10 different nations in 4 continents expressing more or less the same effect. It's noisier, mostly because of China. If you have an Apple computer, like I do, and many of you I see have an Apple computer, this is the place where it's assembled. And you see essentially the same effect, that the value of economic linkages, basically that's what GDP measures, as you go to larger and larger cities, doesn't matter where, tends to have the same property. And this is actually just sort of the bigger teaser. It's a bit messier, but these are quantities that are not just wages. There's wages and GDP. There's also other things that socioeconomic, crime, and in this case patents, so a measure of technological innovation. So all these things that socioeconomic tend to have this behavior, both good things and bad things. So it's starting to paint a picture, something the economists and geographers have known for some time, but basically that a city is really a place to create a social environment with economic products, but also other products, that tends to be magnified not linearly, but sort of super linearly, as we say, with the size of the city. So where does that come from? It's sort of an interesting, so if this is quite general, then I'll spend some time telling you where this comes from. And this starts allowing you to think about the city, I think, in a slightly different way from what you may have thought of. So this is just saying the same thing, but has a new plot. So this is the same one I showed you. This, again, American cities and GDP. But what I'm showing you here on the left are actually the volume of roads. So all the road surface in American cities. Kind of weird thing to think about, but when you look at it from a satellite, or when you look at it from, just the point of view of infrastructure, you may ask, how much road should I have in the city, right? I'm sure that's a problem you have in Stockholm as the city has been growing. And from my hotel this morning, I could see all the traffic happening in the morning and everything speeding up. So you see that this is really an issue. And the answer has been, this is not really coordinated, but the answer has been that you build, so you see that this is the proportionality line, the one-to-one line, and now that this number is less than 1. So what this means is that there's less road surface per person in larger and larger cities, which is kind of interesting. It's expressing something that we all know, which is that space is denser. But it's expressing in particular the fact that in terms of infrastructure, in this case roads, there has to be more use of that infrastructure per unit time, per unit person. And that means that infrastructure is going to take a beating. It's going to cost you more to maintain it and repair it. But also means that it's more prone to congestion and other effects. So it's sort of interesting that this happens, right? And that this effect, in fact, I'll argue next, is the same effect, sort of backwards. So the densification and the acceleration of socioeconomic life are actually integrated into the same, at least general dynamics. So let me show you a little bit how that works. I wrote a paper a while ago about that. So I've been saying this now for a while, but now let's do it. So what we want is really sort of an integrated picture with a little bit of mathematics that explains this sort of thing. So this is Mumbai. It's a nice picture that I like because it's showing you the infrastructure, of course, which is a problem here in the city, but the whole point is that it's showing you that socioeconomic life, the movement of people, all this blur, so to speak, which is actually what the city is about, is what you want to capture, is what that blur is in that other space that's basically conditioning how we move and how we interact with each other, of course, not just in train stations. Okay, so the way to do this is to use a lot of what has become, certainly I think also in engineering, but it's become a big tool of complex systems, which is the idea of networks. So networks are just a way of trying to capture the interaction spaces of several complex systems. In this case, as you can see, so this is a sketch, of course, but we have different people, and I intentionally have them look different, men and women and people of different sizes and shapes, etc. And that's part of the point, as I'll show you, you know this as well, but you can quantify this, that as you go to larger cities, you tend to also have people that functionally are different. They know different things, they do different things in their jobs. So there's more of that in larger cities. But basically, there's a sense in which this person, for example, our hero, here is connected, interacts with many different people. For example, maybe at work, maybe she buys coffee from somebody, maybe this guy fixes a car, maybe somebody else is a friend. And so there are all kinds of relationships, some are economic, some are not, that effectively is what the city is for. And it's the fact that the city is denser and allows you to move more that allows this sort of network to be formed and to change all the time. And so that's sort of the socioeconomic way to just get in and start saying, what is it that's being formed socioeconomically? And this is also interesting. I think some of you, from what I could understand from the Swedish, you were talking a little bit about technology and social networks and the role of how some of these things are changing our lives somewhat. And part of the point is that I think while some of the new technologies are changing our lives socially, they're also in some sense revealing things that we've done for a long time. They're revealing sort of this kind of phenomenon, how we connect to other people and how it becomes easier to do so also through technology. But cities are sort of the old technology to do that. Okay, so what we're going to do is that we're going to create this mathematically is a graph. It's just basically a matrix. You have to measure what these links mean and what these nodes mean, but you get an idea of what they are. But I'll show you later essentially what it means. But what I'm going to do is that instead of just having a social network that you've seen certainly, pretty pictures online, I'm going to put this in space. Okay, so I'm going to put this in the space of the city. And so I'm not a designer, and this is my very crude representation of what a city looks like. Okay, so the gray blocks are places where you have buildings, like here, and people are inside, or live inside, or do business. And the roads are supposed to be the white and green and yellow. And so the point is that our hero here is going about her life, and as she goes about her life, she lives here, and she goes places, like you're here now, so at this moment in time, at this place, you are here. And so, and in these different places, basically, she can interact with different people. And as she interacts with different people, she exchanges things. Things happen, right? So she may catch a disease or give someone a disease. She may find someone she likes. She may earn some money if she's going to work or if she has some trade or whatever it is. She may learn something. She may have fun. It's, really all the things. Imagine all the things that you do with others in social economic spaces. So that's sort of the idea. So this is a very simple picture, but it turns out it's quite powerful and starts informing a little bit how cities work. So you imagine that essentially you have to explore space and be in time to meet people. And in a city where you no longer produce your own food and your own water and your own basic things, really this is the kind of the space that's at play, is the kind of exchanges that happen between people. Okay. When you go to a larger city, what happens? So I already told you a little bit part of the solution from data, but part of what happens is that the space is now denser, so there are more people in space. And also I'll show you a little bit later that, that the roads and the spaces change a little bit in their nature, so the house gets a little smaller, but the big roads get a little bit bigger, so you have highways and things like this. And this is all actually predictable, but it turns out that what happens is that with the same effort, basically, going around the city in the same way, there are more people to meet, more businesses to go to, more things to do, more diseases to be caught, et cetera, et cetera. So there's a sense in which, even with the same effort, because this space is getting denser with opportunities, doesn't mean it happens this way, but it happens on average more this way, there's a way in which the exchanges of all these things can happen faster per unit time. And that's the essence of what a city is doing. It's basically accelerating the kind of socioeconomic life you can have with others, and by creating these denser, more coordinated networks, it's also producing something that's very important that we'll see later, which has a lot to do with what we're doing in this room right now, which is that allows us to specialize, to become more ourselves, to learn new things, and then to, in some sense, exchange that knowledge with others. So it's part of the old argument for specialization and the division of labor, but really in cities it's about knowledge and the things that we do with each other, and the fact that to find a niche for ourselves, we need to become a little different, at least in terms of what we know and what we do, from others to some extent. Okay, so you can measure that with professions, for example. So I want to say now a few things about space and how it gets organized, and then I want to talk a little bit about diversity and this effect, this functional effect of change. So I'm just, again, showing you some cartoons and then not show you a lot of data on mathematics, but this is actually a settlement. It's a very small village, and it turns out it's an Aztec village, because I work also with some archaeologists who have this sort of data. It's a very small settlement with about 50 people. And the yellow things are basically houses. And so it's sort of the simplest question you can ask, and if you're a geographer, this is a little bit connected with models like Alonso's model, et cetera, but it's a little different too. So the question about this is just the question about density. Why is that space that size, basically? So that's just, you put it, if you're a mathematician, you put a ring around it and ask what the radius is, but basically that's a characteristic spatial scale for how big it is. And so why does it have that size? Why isn't it smaller, right? Well, why isn't it bigger, right? Just a very simple question. So why does it have that density? And so what you find actually is sort of very interesting, and it's the beginning of how settlements get organized in space, which is that what people seem to be doing is that they're doing two things essentially. First, they need to exist and live somewhere, so those are the houses. But then they tend to basically meet their neighbors regularly, and they do so by traveling through space. So there's basically a reason, if you live there, that you want to have neighbors, so you derive some benefit. We don't know what it is. They were farmers. These people are relatively simple lives, at least in terms of what they do relative to what you may do in Stockholm. But the idea is that they're trading off two things: the effort to go and visit neighbors, so the effort of walking around, with the benefits and satisfaction that you get from doing that. It turns out that the second effect, the social effect, is proportional to density. So this is the number of people, and this is just the area, so the area of that circle. And this is basically the effort, which is proportional to the radius, so how long you walk, which is this. And it turns out if you put that together, you got a very simple formula that, to my knowledge, was first discovered by a Swede, a guy called Nordvik in the 60s, as he was looking at Swedish cities. But it basically says that the area of cities, it's actually sort of just the broad area like this, the radius, goes like the population to 2/3. So it actually is getting denser, as you can see. And this already tells you a couple things that are very interesting. First, it tells you that if transportation costs here, C, go up, then the city becomes smaller, right? But if they go down, which is modern life, the city kind of gets less dense, more diaphanous. The other thing that you also see is that if the city gets richer, which is basically the G, you might expect perhaps that it would get denser, but it doesn't. It tends to get also more diffuse. And so when we look throughout the world, we're seeing that cities are growing very fast, but we're also seeing that they're going even faster spatially. And this has been a bit of a puzzle. So I'm not saying this is the entire explanation, but it gives you a little bit of a handle on what's happening, okay? So, but this is not the way space is really organized in cities. So I want to start a little bit from history and just give you a sense of how space is organized. And I'll start with this because it's simple. So this is York, sort of old York in England. But this is a series of maps. I love maps, so I always use a lot of maps sort of as illustrations. But this starts showing you, see, how space is organized. And you see this in every city, every contemporary city. So what you see here is that the white space, this sort of cream color space, are basically roads and public spaces. And you see that houses are organized in blocks, often in medieval cities and in many European cities still today, with little gardens on the back. And so this is kind of different, because now you have a segregation of private space and public space. It's been discussed much in the literature on planning. But it's telling you that you need to start separating these two spaces as cities get larger. And the reason for this is that if you don't do that, the city just becomes so congested and so difficult to understand and move through that cannot be. So most cities go through this transformation that we also see in historic cities, in archaeological cities. This is the city I grew up in. It's Lisbon, but this is in 1500s, and I think there's another Portuguese there. But this is sort of a map of the same period. It's a much larger city. This is a city that might have had 500,000 people then, but it has essentially the same character of being organized in blocks, now denser, as you can see, but essentially the same sort of thing. And this is what you see also when you go to even much, much, much larger scales. This is now Shanghai, and you start seeing cities. So, for example, you can see cities now from the air. You can see every city on Earth through night lights. This is what this is. So you just see what is bright in the sky. So this is how, if 2001 had actually looked at cities at night, they would have seen a lot of this, actually, as the features that we've built. The Earth looks a little bit like the galaxy now, so it's very interesting because of all the things you've built. But you see basically that this is just telling you where all the roads and built spaces are. And you see a lot of this structure that cities tend to have clusters that are denser, others that are less dense. These things are all connected through this sort of circuit-like mesh. And that's basically how urban space gets organized always. It's very interesting, and this again has a formula for it. It's the same formula for how, when you go to the beach, where you should put your umbrella. So I know we're in Sweden, but if you go to the beach, you have a dilemma, right? So where should you put your umbrella? And most people, so this is not exactly the same problem, but if you do it like this, it's the same problem. Where should you put your umbrella, right? And if I were me, I probably would put my umbrella maybe there, or maybe there, right? So what you're trying to do is something similar again. You're trying to find a place that's close to people, but not too close. But what that is actually depends on the density of people that are already there. So if it's very dense, you'll have to be a little closer. And this is basically what happens. As cities grow spatially, they also need to connect you to that space that already exists. And they do that partly because of the cost of land, but also the cost of infrastructure, on a length scale that's commensurate with the present density. So when you do that, this sort of space, this is now made up, it's not a real city, gets this organization they already saw in maps, which is that you start having these sort of two kinds of spaces. And this tends to lead then to a different exponent here that is the exponent you see on the data. So this is basically 0.83, which is what I showed you for American cities. So there's this interesting restructuring of space that becomes very important. And that is basically telling you how space is getting organized to permit flows over larger distances, but also private spaces. And this turns out to be very important because it doesn't actually, I was telling you this always happens, but it does not always happen. So a place where it tends not to happen is when cities grow very quickly and there's no planning. So what you're seeing here, we're talking about South Africa. This is Cape Town, not Johannesburg. But this is a township just outside Cape Town, and it's a little hard to see, so there's a graph on top. This is what we do, and I'm not going to tell you too much about it. But basically, there's an unplanned neighborhood, this one, and this one, and this one, and there's what they call a planned neighborhood. I can assure you that if you're on the ground, it doesn't look very different. But it turns out that this neighborhood here has the characteristics I was telling you about. Each house has access. And each house, because of that, has sanitation and water and everything. It's not great stylish things, but it does have services. Whereas in here, what the yellow is showing you is the levels of encapsulation, how many different houses and backyards you need to go through in order to get there. And it's very, very dense. So a lot of the problems of big developing cities like this that were built by hand is that they're not built according to this logic of service space, movement space, to allow you access to each structure, and because of that, it's very hard. Many of you are engineers here, you know this. It's very hard to actually service with infrastructure these places, or even send an ambulance in and so forth. So part of what you can do is to analyze what is the mathematical structure of these spaces. Turns out it's a topological problem. If you want the paper, we just finished it and submitted it, but there's a way to reconfigure this by deforming space in order to plan it and create access. And basically, it's how to disentangle the space in order to create accesses. So this is an image that's from Las Vegas, Nevada, but it's basically showing you again, like that image of nightlights, how the road system actually ends up filling space. So what you're seeing here is very strange, because you see this a lot in slums, but this is Las Vegas, Nevada, one of those horrible American cities created by planners with cookie cut, or things where all the houses are the same. But people in the United States love cul-de-sacs, so these kind of things where you end up at the end of the street with a bunch of houses. And partly it's because it's private and creates sort of this space for a bunch of families. They all have kids, the kids play together, that sort of thing. But this kind of structure on a larger scale, because it's America, not South Africa, plays out a lot in slums, where basically accesses tend to be not throughways, but ways to just get in and get out with a lot of cul-de-sacs. So there's a lot of interest in that urban spaces, even though some are bigger and some are smaller, end up having a lot of the same general topological characteristics, even though they have actually different shapes. So I'm just going to show you a few formulas and then go on to more images and finish. How much time do I have? About 10 minutes, okay. So there's a way of understanding basically how social space, built space come together in terms of creating these denser interacting social networks. So part of the idea is that what cities are effectively places where you can mix with other people, with strangers. You can meet them by putting some effort into moving around and then moving around. And once these spaces are structured and therefore not sort of organized hierarchically, but allow you to move around through space in these ways I was showing you, you end up with a structure of social interactions, doesn't matter what they are, that very simply has these characteristics and basically has this superlinear effect where the networks that you can create get denser and denser. So you have more and more people interacting with each other. And this has a lot of very interesting effects, some of them dear to the engineers, some of them to the economists, some of them to other people. So for example, it means that infrastructure, the amount of volume that it takes, grows faster than land surface, which creates lots of problems, and you're familiar with them here, because you're burying a lot of stuff in Stockholm in the ground, for example. You need to do that in the center of large cities. The other thing it creates, which is very important for policy, is land values. So land values compound these two problems. Both the fact that social interactions get more productive per capita, but the fact also that the city is denser. So that means that the amount of money on the same piece of land is higher than incomes, rises faster than incomes with city size. And it's very important that cities are able to capitalize on that in order to keep on creating services, because if they decouple that logic, then usually, these things get out of whack and cities are very difficult to service. So let me just illustrate a few things. So there are big cities get big pipes, and lots of them. So for example, the pipes of Tokyo go 3 times around the Earth. It's kind of amazing. This is an American city, but basically you start seeing that the infrastructure has to go in the 3rd dimension, either underground, which is more common, but also overground. And in fact, around here in Stockholm, you kind of see that and how it was resolved and how it will be buried, and it's kind of people end up a lot of time talking about this, but there's a sense in which probably Stockholm will double in your lifetime. That's what we thought is growing about 2%, so in 35 years will be double the size, so it will look more like, Berlin or Madrid or something. So how are you going to do that? So you have to think that a lot of the infrastructure that needs to be larger and grow cannot exist on the surface. So a lot of it has to go into the 3rd dimension, above or below ground. And if it doesn't, this is what happens. So this is Rio again. But you see this a lot in developing places where the socioeconomic city has already happened, but the sort of infrastructural city is not caught up, or it has caught up, but sort of in an improvised way. So obviously this cannot be. In New York, actually, something like this happened, and it was documented. There was a big, so this is New York in 1890s. This is a drawing, so you can imagine it's more like Rio. But basically what happens is that there was a big ice storm. Doesn't happen that in Rio. And then after that, they just bury the cables. Okay, so the part of the idea is that you should be able to also look about what cities will look like in the future, right? So this is the city of Star Wars. So we had sort of a science fiction here theme, but basically the idea here is that this is the planet city, when a whole planet becomes a city. But you see, in light of some of the things we already talked about, you see that this is kind of silly. It's probably not the best thing to put your traffic, not sustainable, to put your traffic in the sky. You should put your traffic probably on the ground, spend a lot less energy and so forth. But, but this is a solution. As you can see, it has to go into the third dimension. Okay, so, but cities are really about people, right? Cheesy, sorry, but let's go back to people. Okay, so, and let's go back to this issue of interdependence. So this is again not science and engineering, it's Desmond Tutu, but with going to the South African theme. I mean, there's a lot of this kind of thought actually goes back to Aristotle and Plato when they're starting to debate the nature of human societies, and echoes throughout the history of thought, which is really this idea that we're sort of a very strange species in which, as he says, a lot of what we seem to rely on, uncomfortable as it is interdependence. The fact, this kind of thing, that we need to talk to each other in order to do our jobs and so forth. So this is now showing you how to use different kinds of data. This is Portugal, but we've done similar studies for other countries. Studying the social networks so now you can actually measure the social networks, but people on the phone. So cell phone networks, because that leaves a trace. So this is an example, like online, where you can start following the social networks of people and see where people are, who they're talking to at what time. It's kind of a little scary, but it allows you to actually start seeing the physical traces of the things that I've been talking about. So as you basically see these effects, it's exactly the same effect, which allows us to think that we're on the right track. But you also see sort of a bunch of social structures that seem to also recur even in larger cities. So this seems to be one issue, is that basically, just as I've been telling you, you do see that people in larger cities just talk to more people on the phone and therefore probably also interact with more people more generally. And this is how we're starting to understand it. There's a logic to this that goes back to very old ideas and important ideas in economics, and I already alluded to them, but it's basically this idea that what is it that happens in human societies that actually leads to this urbanization and development that's predicated on interdependence. And so what you tend to see is that old societies, not necessarily, they're poor by today's standards, but they're not poor in other ways, but they tend to have people that are doing the same thing. So a society where everyone's a farmer, more or less, people have a lot of knowledge about their environment, but that knowledge is replicated. Every farm, more or less, needs to have that knowledge in order to survive. So that knowledge does not accumulate, because there's this redundancy of knowledge. So the way human societies go about breaking this dilemma is by creating cities and creating environments more generally where people can become interdependent. And therefore, you become more of a manager, somebody becomes more of a scientist, somebody becomes more of a pastry chef, somebody becomes more of a Thai chef. And it's out of these exchanges that each person actually acquires more knowledge about what they do and puts, in some sense, more knowledge into the system. So you can measure this, for example, very interesting to do it in Sweden. We were talking a little bit about it yesterday. How is it that environments foster this sort of interdependence, and what are the costs of doing this? And this is, in some sense, the old argument now replayed into modern technology. So I'm 5 minutes away, and then I'll finish. But I just want to now get to a more and more complicated picture as we play this forward. So we already alluded to this issue of time and a certain acceleration of things that happen in the same amount of time. But this is also a very typical sense that we have, that in larger cities there are more things that happen per unit time. I showed you already there's more GDP per capita per year, more patents per capita per year. So a lot of these socioeconomic things seem not only to be more intense in space, but also more intense in time. That's one way of seeing it. And basically this is because, again, the rate of interactions per unit time is going up, and it's allowing all this to sort of be lifted with that tide. So the way to measure that too, so I already showed you this, is just GDP. But there are ways in which you can even access this in terms of how people behave. So this is not a very good data set. I showed it more because it's funny and interesting, but it's not because it's super good. It's walking speed. And so what you see is that it tends to be true that people in larger cities also walk faster. So the logic by which your time is worth more money because you earn more wages also seems to be leading to a general effect where you're trying to minimize time in between stuff. So that seems to be consistent with this. So there's these rhythms at which the city and the social system tends to develop as it gets bigger seem to be consistent both with rhythms in your own life as an individual, but also in these aggregate effects of productivity. And it's sort of a bit of a joke, but we know that this is true because this experiment is done every year. So every year people go shopping in New York City for Christmas, and here's what people from New York say about those tourists. I'm sure you have the same thing in Stockholm when people come to Stockholm for shopping and they just don't move, they don't know what to do. And so there's it's an interesting disjunction, right? I mean, if you go and buy a cup of coffee in New York, you got that cup of coffee fast, and that's the way it should be, right, in a coffee shop. But but that's not always true in many different places because indeed the value of time and how people use time is different. Okay, so I want to finish with this issue of diversity, which is both, diversity sounds like a nice word, but I want to actually say it in a way that diversity could be inequality, and it has to do with the use of space, rich neighborhoods, poor neighborhoods, and how all this comes together to form cities. And I think this is a lot of where our work is now, is try to understand these patterns. And so I just want to show you a little bit of this because, again, you have extraordinary access to data and interesting things in Sweden that may allow you to do a much better job than we can. So let me just show you a couple of things. So New York is very diverse in terms, again, of cities. This is a quote from Charles Darwin, which says that diversity is very important, of course, for selection in biology. But what's interesting is that if some people are beautiful, then some other people have to be ugly, right? Some people are rich, some people are poor. So is that good or bad? How does that work out? So this is a little pixelated, but it goes to saying that when people think about space and the use of space, this is bike thefts in San Francisco. So you see that most bike thefts happen here and there. And this is typical of crime, it's typical of certain businesses, is that space is used very unevenly. So again, very great diversity in how space or time is used. And this is now income so for those of you who know New York City, this is New York City, so it's a big city, it's the metro area, this is Manhattan here. And so as you can see, there's tremendous spatial diversity in terms of wealth, this household income, or poverty. And you see, in fact, that there are places that are very rich. This is the Upper East Side, richest part of New York, but they're very close to other neighborhoods, little neighborhoods that are very poor. So this pattern is just very complicated. And it's a lot more complicated than what I was showing you in terms of just saying about how the average wage in New York works or what its value is. So you'd like to really understand this and understand in some sense how it moves. How is it that this is part of the picture in which you have hopefully improvements in wages and economic performance and social use of the city, etc. So we're studying this a lot because it's very interesting, because you see that even though you have distribution of incomes, this is what you see here, they're very different in different neighborhoods. Once you put all this together again, you got basically a Gaussian curve. This is in log, so it's a log normal, but it's a very, very simple pattern on the aggregate that is very, very different in each neighborhood. So basically there's a sense, which is also intuitive, that different people with different amounts of money live in different neighborhoods because of real estate, because of preferences, because of history. But this really is a complicated pattern that's also simple all at the same time. And it's also fairly dynamical. So a lot of these neighborhoods have been poor or rich for a long time, but some others, particularly, for example, in Brooklyn, are changing very quickly. So you'd like to understand if this is good or bad, if this is giving people access to a better life, it's stopping them from doing that. And this is the kind of thing that's very difficult to decide, but this is really how space and time and social life comes in play in detail in cities. So what you see here is basically these are the filters by which where poor people and rich people tend to be selected to live, as we say. But the point is that then you can characterize the neighborhoods that are very different from the city in terms of their distribution of income, and the neighborhoods are very much like the city as a whole. So the gray ones look just like the city. So they have rich people and poor people and everyone in between. But some of these red ones do not. Either they're poor or they're rich. And what you see, for example, this is presumably related to real estate markets, is that the richest people here are the ones that are most segregated spatially. So they're the ones that choose where to live, and where they live, there are only people like them. And then poor people are the ones that are most segregated, and then people who are middle class seem to be everywhere. So it's sort of interesting, again, how the city is connected, in this case, across income, but you could think about other dimensions like education and other things in terms of how its spatial patterning works. And this is sort of interesting because people are starting to ask, how is it that these environments condition what you'll be able to do as an adult, as a citizen of the future. And how is it that some of these places are creating opportunity or lack of opportunity in order to do that? This is relatively difficult to do with American data, though people are using tax records to do this, and there's interesting work happening. But it's the kind of work that I've heard people talk about being possible, for example, in Scandinavia, because you have more records about people, in order to try to understand, again, how social life, neighborhoods, services, real estates, all come together in terms of creating this sort of dynamics of social life in places, and how it actually produces a life or process of development, both at a personal level and how that aggregates up to cities. So this is my last slide. It was sort of a big tour full of images, but hopefully I was able to convey to you there are a lot that we can learn about cities. Certainly there's a lot of data, and there are a set of good questions that are allowing us to start understanding how cities work and what they do, both at individual level and increasingly at the collective level. But cities are places of great change. So this is basically Shanghai in 25 years, and how we went from relatively small city for China to this. And even in Stockholm, when you think about what Stockholm would look like, as we said already, you expect it to double in your lifetime. So that is likely to be, at least for Stockholm, a big change, perhaps not as big as this. But it really begs the question, as people are attracted to these intense socioeconomic environments and sense their potential, whether we can realize it and sustain them in equilibrium with the Earth's natural systems. So, thank you.
Thank you. So your studies suggest that all cities grow in the same way. Is this common knowledge, and how can a modern city planner of today use your research?
It's somewhat common knowledge. I think what we can do today is to be a little bit more quantitative than ever was possible, and that allows us to really zero in on what's common and what perhaps is different. I think in terms of city planning, there are several questions. One is, a lot of city planners are more concerned with the physical space of cities, land use, as a few things that are traditional tools for city planners. I think what a lot of this emerging body of work, not just our work, but a lot of people in economics, sociology, working on all this, is this issue of integration. How is it that spaces and social lives are integrated over the metropolitan areas of cities? So a lot of the problems of cities, increasingly as they grow, are not just of the old political unit, but of the larger area that captures the integrated life of individuals, the economic life, the social life, education, all this. So that is sort of interesting, and I think opens, a different perspective, and then a set of things that can be measured and tested in urban planning, sort of as a more data-informed practice. I think the other part of that question is, what should we all do, but mostly it's not our problem in some sense, with the really large cities that are emerging throughout the world. So those cities don't have strong governance. There's no choice for somebody to come in with a lot of money to change completely their infrastructure. And that really is begging the question, how is it that we can understand what's already happening in these places well enough that with a minimal amount of effort and investment, we can actually steer these cities towards the path of development and improvement? That's a deeper question, but I think that's the more important question ultimately.
Might get back to that one in the panel. Do we have any questions? Okay, I would like to ask you, I have at least the perception that our social ambitions and our ambition to keep a distance to people, that differs between different countries.
Mm-hmm.
For instance, I think we Swedes are not considered to be extremely social in that way. We have this distance. So that would apply that city planning and the Swedish cities should be less dense, for instance, than the Italians or the Portuguese or whatever. If
Yes and no, right? I mean, also Swedish cities are relatively old, so they were, at least their centers were built. You see all this in Stockholm now today, but you see that the city centers at least were built before cars existed, so they're walkable. And then the largest city actually is a city that's very much a car city as well, right? So people commute over large distances. So the density is also dependent on the history of the city. Yes, cultural factors are important, but often the most important thing is that we don't need to be on top of each other to in large numbers to do all the things I was describing. But what's really important is that we can meet, be safe with each other. So the city really works at the level where strangers, people that don't know each other, they're often very different people in terms of what they know, in terms of their personal history, their ethnicity, can deal with each other. Often sort of business, right? But it may not be business in terms of money, but dealing with each other and finding ways to interact with each other in positive ways, that's the essential nature of the city, and that can be realized in many different ways. But it's often not something that's even that monocultural, right? Okay. Even the challenges of Stockholm and other cities is how do you increasingly integrate people that are very different in your urban spaces, and also don't disperse them in suburbs that are so undense that the possibilities go unfulfilled. There's maybe a question there.
Yeah. Please use your microphone.
Do you hear me now? Yeah. I actually have a question about, because you're talking so much about, you're talking about social relations, okay? And then you're talking about the quantity and the ties and the links between people, and that's a way to measure. But I'm actually interested in the connections and the links between the amount of social relations, I mean the quantity, and then the quality. Because what we see now also is it's an explosion of the quality. I mean, quality-wise, a lot of things are happening right now that we cannot really understand yet. Mm-hmm. Because you're talking about people in the city that mostly they don't know each other that well. Right. And what do that do to the quality of the social relations? And because this is linked to health. Mm-hmm. And okay. is your research linked? Do you see the links between that one and health questions?
The quality is usually a little bit harder to measure. So there are things that are relatively easy to measure that I don't think answer your question. But for example, you can certainly use cell phones and mobile devices, and we've done this to see how long people talk to each other and how repeatedly they talk to each other. So the same pair of people. So that's relatively easy. I'm not sure how much it tells you about, some of your questions. But part of the problem in trying to capture what's general about a city is that it's very hard to start saying, this interaction was about buying coffee, that interaction is a health interaction, that interaction is about learning. I mean, what's interesting is that we bring to an interaction all kinds of things. And part of what's interesting about environments where we can meet face-to-face is the discovery of each other in terms of what we could do together that's good versus what's bad. So a lot of places that work well, for all I mean, I think Sweden seems to work very well, are places that allow people to come together in socio-economic environments and find something that's positive to do instead of something that's negative, which also happens a lot in cities in times of crisis or in environments where there's less of that cultural norm or regulation. So in some sense, the city is really a place that's sustained because of the positive social interactions across all channels that can happen. Their quality is very variable, but it tends to also improve over time generally with what we think of as being developed. Most interactions in more developed places lead to less fatal diseases and to more money than in other places. So that process by which the nature of the social interaction changes is very important. It's really at the heart of what personal and collective development is, but it's still not very well understood, and it's very hard to measure. But it's a very important question.